we already tested our APIs in different ways. Via the test step, when we designed the API endpoints, and via the HTTP file in Visual Studio, or by directly sending requests in the browser. Those are common ways to do that. But testing like that is often not sufficient. To really test and debug an API, you often need a full trace, especially if your API accesses other things like functions or app services downstream. That is where the trace option comes into play. Let's open our function app endpoints, get itineraries for example, and let's send a request to test this. Just sending it now won't work anymore because we now require an incoming token, as you remember. So I need to add an authorization header here with a valid token as a bearer token. The token we previously generated should be valid for an hour, so hopefully I can still reuse that one. Now let me paste that in here. Alright, let's send the request. And that worked out just fine. So I send the request and I do get back some useful information. We get back the response headers, we get back the response body, but this is often not sufficient to figure out what exactly is going on. For example, I don't know, by looking at this response, what downstream services were accessed. Now, you obviously don't need that as a regular consumer of the response, but when you're developing something like this, you sometimes do need that to figure out what's going on. So I'm going to try the trace option now. So instead of clicking send, I'll click trace. All right. That still worked out. And if I go to the trace tab now, I can see a full trace of my request and response going through all the different components that we configured. So what do I see here? This is the initial request, including the bearer token that was sent. Then we see that Azure AD JWT validation succeeded. That's the first part of our policy. Then we see that the authentication managed identity policy was executed and that a managed identity token was added to the authorization header. And then we go to the backend. We can see that the request is being forwarded to the backend service, and we also see all the headers that were set. What you can see here is that the authorization header is indeed set to bearer, followed by the token generated via that managed identity. After that has succeeded, we get back a response from the downstream service, and that is then eventually sent back. So, as you will probably agree, something like this can come in really handy when trying to figure out something that's going wrong. But we are on the portal now. You don't necessarily always test via the portal. You sometimes test via something like Postman or Visual Studio. You can also get a full trace like that, but it does require 1 or 2 additional steps. The first thing you need to do, as far as tracing is concerned, is ensure that tracing is enabled for your current subscription. So let's navigate to the subscriptions. And we are currently using the Travel Inspiration product subscription. So if I click that one, I can allow tracing for this product. Let's click Save. All right. Now tracing for the subscription key related to the product has been enabled. And then the second thing we need to do is, next to passing through that subscription key, also pass through an OCP APIM trace header with value true. All right, let's send this request. That worked out just fine. Now let's have a look at the headers. So these are my response headers. And what you can see here now is an OCP APIM trace location. By copying this URL and navigating to it, we see the full trace just as I've just shown you on the portal. This already goes a long way towards figuring out issues. Now, of course, application insights, log analytics workspaces, and so on are also supported in APIM, But we've seen that a few times already. It's not different from how you'd set it up for other Azure services. So with that, it is now time for the section summary. We learned a lot about Azure API management in this section. Imagine you're building a bridge between people who use an API and the backend systems that provide the data. Azure API management is like that bridge, but it is more than just a simple crossing. It has three main parts: the API gateway, the management plane, and the developer portal. The API gateway acts as the entry point for API consumers. It handles tasks like routing requests to the right backend services, verifying credentials, transforming requests and responses, enforcing rate limits and caching. The management plane is the toolkit for the company providing the API. It includes tools in the Azure portal or CLI to manage, package, and monitor APIs. When you're working in the Azure portal to manage APIs, you are using the management plane, so we did that a lot. And lastly, the developer portal is an automatically generated website that documents the APIs. Developers can use this portal to learn about the APIs and how to integrate with them. We looked into all three of these, mostly focusing on the API gateway and the portal, of course. A few key concepts stick out when working with API management. 1. APIs. These are the core of the API management service. Each API represents a collection of operations linked to back-end services. You can customize these operations extensively, controlling URI mappings, parameters, and more. As you learned, you can create an API manually, but you can also import them from, for example, an OpenAPI document. Importing is often easier for large numbers of endpoints. Once added, you can define operations and set up policies for each endpoint. These policies allow you to modify the behavior of an API through configuration. The policy is another key concept. They can enforce rate limits, transform requests and responses, and more. Policies are executed in sequence on the request or response of an API. We created a few of them. And the last key concept is that of a product. A product is a way to package and present APIs to users. Products can include one or more APIs and be open or protected. At this level, two policies can be applied. Protected products can be protected with a subscription key for access. Talking about security, there's more than just a subscription key that can be important and or can be used. For downstream access, use managed identities. Also, apply IP restrictions to ensure only authorized services can access backend APIs. And for incoming requests, it's a good idea to require tokens to validate access. Lastly, testing and debugging. You can test an API endpoint on the portal or via a tool like Postman or simply by sending it in the browser. Often simply sending a request is sufficient to validate a request, but sometimes you need more, especially if you need to fix an issue. In that case, you can enable tracing for the subscription key. Like that, you can get a full trace of the request and response flow. And that's a wrap on Azure API management. There's one more service I'd like to cover: Azure Event Grid. On to the next section. In the last section of this deep dive course, which, as you've seen, very much focused on Azure's commonly used serverless offerings, I want to dive into the last of the, in my opinion, commonly used and important serverless offerings: Azure Event Grid. I'll first introduce it, so you can already get to know the scenarios it can be used for. Just like in the other sections, I'll then cover the key concepts and we'll create an Event Grid resource together. Then I'll implement a few common scenarios. We'll integrate blob storage with Event Grid and a function app, and we'll integrate with Event Grid from our own custom .NET code. Along the way, you will learn how to secure access to Event Grid, and you will learn how Event Grid can improve the reliability and resilience of your system. Let's dive in.